I will be introducing the moderator, Mr. Prateek Joshi, and then he will introduce and moderate the panel. I'm Clara, I'm the conference chair, and it has been a great time for 3 days looking at you smart people, where the limelight should be really, and then all the eminent speakers and experts. Now the panel will cover deep learning for IoT. That's the theme of the panel. And just to give you a little background, and we have an exceptional panel moderator, Prateek Joshi. He's an artificial intelligence researcher. He has published 7 books, and he's a TEDx speaker. He's the founder of Pluto AI. It's a venture-funded Silicon Valley startup building an analytics platform for water resource management powered by deep learning, which is a very important thing in the whole world these days. And his work has led to patents. He has done papers in IEEE conferences, worked for AT&T, Foundry, done a lot of Silicon Valley deep learning work and Open Silicon Valley. And he's author in tech magazines as well. And he is going to moderate the conference. He has graduated from University of Southern California with a master's degree specializing in artificial intelligence. He has worked at companies such as NVIDIA, Microsoft Research. You can learn more about him in prateekj.com. Go ahead.
Thanks. Yeah. That was thanks for the introduction, and we have a pretty exciting panel today. Between them, they've pretty much seen everything there is to know in data science and AI. So I'm pretty excited to be on this panel. So what we'll do is we'll go around the panel and we'll have them kind of like a quick 30-second introduction about themselves, and once we have that, we'll continue with the panel. So with that, I'll pass on the baton to you.
Okay.
Yeah.
So. My name is Subrahmanyam, or Subra. My experience spans both regular enterprises of all sizes. I was at Bell Labs in the dim and distant past, as well as working with the startup ecosystem, academia, and also management and technology consulting.
I'm Suchitra. I'm Dr. Suchitra Abel. My most favorite school on earth is UC Berkeley, and Professor Lotfizadeh, from whom I've learned a lot of fuzzy logic, but unfortunately fuzzy logic is done more in Japan and Europe than here, so my interest shifted, and I do causal modeling nowadays. I'm finding it very interesting. I learned it first from Professor Jude Pearl of UCLA, and Carnegie Mellon has developed excellent software, Tetrad 5. Try it out and you'll be really impressed, and that's what we are using also for our project.
My name is Feyzi Bagirov. I'm a professor at Harrisburg University, and I consult a few startups here in San Francisco. My background mostly, I started with business intelligence and eventually came into analytics.
I'm James Taylor. I run a small consulting firm based here in Palo Alto, and I've been working around analytics and particularly embedding analytics in automated systems for the last 20 years or so. And a lot of background for that in software and software consulting. Really very much focused on not so much how do you build the analytic, but having built one, how do you operationalize it, make it real?
I'm Dr. Amidan Karib, a VP Associative Computing Unit in GSI Technology. So my background, I live in Israel, so GSI has an office also in Israel, software team in Israel. They acquired my company a year and a half ago. So actually my background is associative computing. Over 30 years I'm working on associative computing. I started my PhD thesis is how to do compute inside memory. I have about more than 30 patents on this type of computing. And right now we are developing the product, the chip, the software, and we'd like to come to the market as soon as possible with this technology.
Great. Thank you for the introductions. So just to kind of kick things off, so today's topic is solving business problems with predictive analytics. And so, so when you look at people who are working in this domain, let's start with people who kind of work with the people who get started, look very young, like budding data scientists. So the first question is to the people like professors on the academia side of things. So how do you see, like, do you see more students gravitating towards data science and AI, or rather, like, how has that changed as compared to like 10 years ago or 20 years ago? Can you talk a little bit about that?
So,
Yeah,
all right.
we can go with all three of the So
I'm not sure I have the best perspective on this, but you know, one of my favorite data scientists is Isaac Newton. So, the word data science sort of somewhere came about, and actually, as I was mentioning briefly at my talk yesterday, one of the, I hope this is not on camera, you know, given career counseling to DJ, DJ Patel, who was sort of credited with coining the word data science, right? And he was President Obama's first data scientist in the White House, right? Yeah. So obviously data science is somewhat of a buzzword, and a lot of universities are offering courses. You have sort of every course online. Yeah. But on the flip side, you know, I run across several people who complain about the lack of jobs in data science, right? So perhaps, anybody has a job, I'm looking for a job, but also I think the conundrum here seems to be that on the one hand, it's a hard field, yet on the other hand, you know, there are lots of data scientists who are looking for jobs, right? So I want to sort of find out, and this person was saying, okay, you know, the data scientists are being asked the wrong questions. You should, you know, really know what a p-value is, and you know, nobody knows, and they're getting jobs, right? So there's a lot of turmoil. So clearly, you know, on the one hand, it's a hot field with a lot of buzz. Yeah. And what was your question again? No. So what's changed in 20 years?
Like, do you see more students? I mean, of course, as you mentioned, data scientist has become the job.
Yeah, but it wasn't there 20 years ago, right? Exactly. It's less than 20 years the word was coined. Right?
Yeah, I'd like to say something, that I don't think either Newton or Einstein had even imagined, could even imagine the amount of data and the type of data that is available to us nowadays. I know that for a fact because last year I gave a talk at BIGS with my friend who's sitting there, Naveed, and that's at BIGS is the Berkeley Institute for Data Science. And over there was a guy from physics who came to started talking about physics data, and I can see why he did that. You know the LIGO project, from which we have Caltech, which is supposed to have gotten a Nobel Prize this year, but somehow did not. They faced data that they could not analyze. They really, seriously, they ran to the data scientists in Caltech and everywhere else to see how can they even understand the data that's coming across in the field of physics. Of course, they proved that Einstein right, and I believe that Einstein will always be right, at least in my heart I believe so. In my heart I believe so. Oh, Einstein, I love you. But what I'm saying is that Einstein could not imagine the type of data that's available. And those data are coming from many different sources, and they cannot even interpret the data. They don't know what that data is like. So data science is becoming very important in the last 10 or 20 years.
And Professor Bagirov, so extending that point, so do you see like when you see students who are coming into this field, do you see them, hey, let me start with some different field, and then like a year down the line they realize, oh, you know what, data science is where I want to be, and they tend to make that change, or are they already aware that, you know what, I really want to do this, let me just do this because it's a hot field, as you mentioned?
So I'll probably the best example that I could present is from Becker College. Becker College has one of the top 10 game design programs in the world. And so there's a lot of designers, game developers, game producers that they put together a game, and if I'm a developer, you know what, I can just put a dog here, and then I can maybe put a flying cat here, and then just put whatever I can and then see what's going to work. At one point in the game, they realized that, oh, my my users are dropping from the first, without actually going through the demo, like in the first day. Why is that happening? So, and then they realize, oh, that data is actually really important. So why don't I go and take some courses that require data? And then when they are coming into the game analytics, for example, they realize that it's actually more, it involves a lot more than just one class. They have to take prerequisites, and some of them are not up to par with it. Game designers are actually not. They're more prone to the art sciences rather than math, for example. But others are actually quite good at it, and they persist because they know what's going to be in for them once they get that knowledge, once they can use the results of their of the data.
That's right. And sorry, I just wanted to kind of get James's thoughts on the industry equivalent of this, right? So when you see like fresh engineers, just maybe 1 or 2 years of experience, right? And when they realize that, you know what, data science is where I want to be, and they do, let's say, a data science boot camp, right? So how does that, like, what do you kind of think about that route, and also what are you saying in terms of like new engineers, not fresh grads, but engineers entering this field?
So I mean, I also teach an extension program, so I also see some
okay, yeah, so that's good.
I think, there's clearly a lot of interest in people who are already developers in business intelligence or data warehousing. They're in a data-oriented field.
Yeah.
Most of them want to add data science. They feel like if they add data science skills, they add that. I know how to use Spark, I know how to use machine learning, they have those things on their resume, they'll get more value. What I don't see is anything like the same enthusiasm amongst, if you like, the rest of the IT sort of community. Business analysts, programmers, there's not the same rush to it. And I think it's because it's, right now in most all enterprises, it's very concentrated in the data science group or the analytics group. And so when you go talk to people who are designing the next system for the call center, they're not talking data science at the beginning of the project. They're not talking it in the requirements. It's not until you get way down the line that the data science team gets engaged. And so I think I'd be happier if I saw a broad and shallow interest in data science. And what I see is a narrow but fairly deep one from a group of people. And I think that's a concern, because it means companies are not getting their IT organizations, their programmers, their analysts to broadly think about data. They think of data as a structure, not as a set of records. And so they care about the structure is, they don't care what the historical data says. And that's a problem for a lot of organizations.
And so, Dr. Akalim, so you have spent like time across borders, right? So do you kind of, does that kind of go across, or what are you seeing in your domain? Like, does that extend?
So in our domain, so actually we are, in our domain we are developing different type of architecture. So the kind of people which are looking, students, is today the university, the people which coming from computer science, I'll just learn very, very high level language and algorithm. So because this in our company, we go back, we're going to change von Neumann architecture. So we're looking for people from very, very, very low level programming. So you can find such a people that can know the basic, Carnot table, truth table, things like that, and write in very high language. So we are. Actually, we prefer a young engineer that dirty, and teach them a new direction. So this kind of people. So actually, I already a few years ago, I already have do some lecture I do PhD in Weizmann, but I do some lecture in Tel Aviv University. So in computer architecture and train them how to do associative computing. So I give them a training and exercises, and I then hire one who do the most optimized way how to do skeletons or image processing. So actually kind of. So what I'm looking for the academic is just to teach people from all the aspects, from the hardware, a little bit from hardware knowledge. Nobody knows what is NOR, NAND, or logic, and we need it.
Right. And actually, that connects very well to kind of the points I think it was mentioned. I think in the beginning where like the p-value point, right? Like it's just people just directly jump into very, very high level like programming skills that are like quote unquote employable, but if you kind of dig deeper, then it's very difficult to find something fundamentally strong. So I think I guess the conversation now is like, how do you kind of bridge that gap? Because if you know p-value or don't know how to write code, they'll not be hired, right? But if you know how to code, but you don't know what the underlying concepts are, it's shallow knowledge. So how do you, like, how do we bridge that gap, right? Is it just like pure like individual hard work, or is it something fundamental about the way we are pushing this out, data science, the hype?
Well, I'm not going to right now jump in and answer your question, but I did want to add a footnote to my earlier comment, which is that I don't really view this from an academic perspective. Right? At the end of the day, one is solving a problem, right? And everything you have in your toolbox you use to solve the problem. So, and data science is sort of the current label for a set of tools that are used to solve the problem. But I think the link between, the business or whatever problem you're trying to solve, and the tools that you use shouldn't be forgotten, right? I mean, if you're sort of mired in the weeds trying to, so it's like somebody who learns Java programming. You still have to know something about the domain in order to write a program that's useful. Yeah, right? That's right. So that's the only point I wanted to make. Right?
I think,
Actually, what you asked is a very hard question, actually, because I really don't know what the answer in real life will be. It seems like, yes, we need both. We need the basic knowledge, and we need the programming skills, and we also need another, the third point that's missing, namely understanding the system that we're working with. There are programmers who don't understand the system; they just blindly program. And there are theoreticians who think, oh, since I know p-value and everything else, why do I need to even understand the system? But there's a necessity of understanding the system. Otherwise, you won't be able to do the teamwork with the systems people there, and also you need to understand the basic practical decision-making scenarios. Like, for example, suppose that you've changed a system in your company. Now, what's the cause-effect relation? What will be the effect on the total activity? If you change one system, there's a causal relation that you have to notice, namely the effect on the total activity of the system. Now, that's understanding the whole system, not just having a theoretical knowledge or programming knowledge. And many people don't have that.
I was going to say, to answer to take your question, I think one of the challenges of data science right now is we're treating it like it's a technology-led thing. A lot of enterprises that I talk to, they're like, oh, well, the first thing we've got to do is we've got to build a data lake. And we got to hire some R programmers, and we got to invest in this technology-related set of skills. And you ask them, well, why? What's it for? How's it going to? That's the investment bit of the ROI calculation. What's the R bit of the calculation? What's the return going to come from? And they're like, I don't know, but you've got to have data lakes. We've got to build a data lake first, and then we've got to put data in it, and then we'll analyze the data, and then we'll hire the, and then in year 5, we'll start trying to come up with a business scenario that we'll remove for. And you're like, not entirely sure that's a good investment strategy. And so, but I often joke with people. I said, you have to begin with the decision in mind. What decision are you trying to get better at? What will that take? What data do you need? And if you work backwards, then you've got some kind of connection to it. But it's hard work, because data science has become hot. And so everyone knows they can get a big budget for data science. Just like they used to be able to get a big budget for enterprise data warehouses or whatever the then trendy data thing was. And so there's a lot of money being spent.
And I think it's, that is, so when you think of like predictive analytics, right, when you said like defining the business outcome first before you build a data lake and spend like 5 years, right? So now the big question is data itself, like collecting the required data. You need data, you need some kind of analytics, but like the cost associated with collecting the data, or even before that, defining what data needs to be collected, it seems to be a huge challenge, right? So how do we kind of avoid that pitfall, or rather, how do you kind of recommend like planning for that? Like when a business decides to do, you know what, we need data science, but that's pretty much it. That's all we know.
I'll take that. So I'll describe the use case I had about a couple of years ago. with the online video advertisement exchange platform. They've been accruing about hundreds gigabytes a day. It's more data that they could store, and their problem was that they had to purge most of it just because they didn't know what to do with it, and it was costly to store it. Some of the things that we recommended was actually understanding what their customers are looking for, what KPIs they're looking for, and understand which which variables will affect that, so they could just keep those variables and maybe purge the rest. Others were, some of the, the other methods that could apply to other companies is actually to switch to primary data collection methods. There's a lot of unintrusive, devices that can, IoT that can collect, sensors that collect data that without actually you, getting directly involved in it. Of course, we're not talking about the online surveys because, if you get 8% back, and that's a huge, only a huge investment, that's great. But overall, I think there are methods. The methods are narrowed down to knowing what you want to do, trying to automate it, and essentially, improving your model.
That's right. Cool. And I think that's a very good point. Like understanding, defining, how do you define success, right? Like when you're doing something, when you're undertaking this huge project. Let's say if you want to store all of this, 100 gigs every day, right? Like you're storing that because you want to achieve so and so, or maybe something might become relevant down the line, right? You cannot go back and retrieve data that's gone, right? So that's a good point. Now that's actually the second part of the question of the cost. You partly addressed the cost of collecting data, right? So in modern things, let's say you have a manufacturing plant, right? Installing a data collection system would mean installing the connected sensors, installing the gateways. That's a big capex involved, and so that analysis, how much effort, or rather, what kind of, apart from hardware expenses, are there any other costs that you need to be aware of before investing in such systems? Dr. Akira, any thoughts on that?
Okay, from point of view of us, so it's things we are working differently in associative. So we do compute inside the memory. So actually, in our concept, that we don't need to load the data in many server and etc. So actually, all the data are sitting in the memory, in the associative memory, and we do the programming inside the memory.
Yeah.
So actually the cost is it's okay, how we improve it, the performance is the speed, as long as we increase the speed of the computing, we improve the latency. So if all the data is sitting in the memory, so we improve the latency significantly. So
I think there's a cost of distraction. I remember I was doing work for an oil company, had an oil field, a lot of old nodding donkey oil rigs, right? Yeah. And many of them don't actually pump anymore. Right? If you ever look at a field of oil rigs, many of them are not pumping oil. And his engineers kept wanting to install sensors and monitoring devices so they could tell exactly which ones were working, which ones weren't. And he was just like, you got to show me it's cheaper to do that than it is to hire someone to stand by each one and watch the gauge, right? And just call us when it breaks, right? Number one. And number two, he's like, if the oil field is still producing, why do I care that it's this 97 of the 106 pumps and not a different 97 of the 106 pumps? I don't really care which pumps it is. And so he had his eye on the value proposition, but his engineers were totally distracted by the fact that they could get this data, right? And I think sometimes the availability of data, it obviously has value, but it can also be it can become an end instead of a means. That's right. And I think you have to say, what am I trying to do? What data are ready to do that, and make sure you stay focused on that data, particularly if you're putting it in memory and trying to do computationally intensive things with it. It gets expensive to do anything to it, and you don't want to do that if there's no purpose.
And so this question again is open to everybody, and it's now the thing is, if you look at the last 2 or 3 decades, AI, artificial intelligence, has had a couple of false starts, right? We can't deny that, because the people get really excited and they think it'll do everything, and it ends up doing nothing, and then people are like, you know what, it's hyped up. So, and more traditional industries seem to have become like, predictive analytics as a whole, there was a time when it got a bad rap. Like you go to a traditional industry like manufacturing, oil and gas, as you said, like they're like, yeah, you know what, AI, it doesn't work, let's just move on, right? So now this way, this again, like deep learning is picking up really well. And so how do we make sure that deep learning doesn't fall into one of those categories? Because it can do predictive analytics really well, but only if we convince the customers to actually use it. So any thoughts on that?
Well, my thought will be that there has to be a lot of work to be done in both academia and industries regarding interpretation of data. See, it's not just the accumulation of data, the availability of data, that's what people are so excited about. But it's the interpretation, proper interpretation of it. And not just the interpretation, it has to be interpreted properly for the context. Given the whole context, are you interpreting this data properly? Or are you just looking at it like, as a bunch of stuff that just fell into your hands? And the whole subject of predictive analysis should will eventually depend on what kind of interpretation mechanisms we have available.
Yeah. Did you have a thought on that?
Well, I have some random thoughts.
Sure, yeah, please. Keep going.
I think I'm the only one here who is young enough to have sort of witnessed all three of the prior generations. And predictive analytics or deep learning is not going to work on all problems.
That's right.
And the requirements are going to be, somewhat problem dependent, to say the least.
Yeah.
Right?
Yeah.
And in particular, I think, to repeat some of what I was trying to say yesterday, there's this issue of white box versus black box models.
Yeah.
So for some things,
That's right.
you need to know
Yeah.
the rationale for why a decision is reached. And in other cases, you don't care that much. Right?
Yeah.
So clearly, it's not the panacea for all problems. And
That's right.
if we're selling it as that, then that itself is a problem.
It is going to go in the trough.
Yeah. That's right. Yeah.
I think the majority of it will come from better understanding from the management on what do they want to get out of the data, because it doesn't matter if that's a neural network or logistic regression. They will still need to understand what questions are they trying to answer with that. And because 90% of the times the customer that has data will throw it at you and say, well, tell me something that I don't know about it.
Yeah.
And then you have to be creative. You have to be, come up with. So you have to so I think it's more of the question of educating others on what it actually can do, and that it will only help you in answering the questions that you're going to ask. It's not going to do things for you.
That makes sense.
Yeah, absolutely. I completely agree. That question is one of my pet peeves, is when someone says, here's a bunch of data, tell me something interesting.
Yeah.
Like,
It's
no.
That's
Yeah.
right.
Tell me what
gotta know.
Tell me what would help you,
Yeah.
and I'll see if the data can
That's
provide
right.
anything useful. Because it's this inherent idea that the data sort of knows how to make your business run better. It's like, no, there are things it, quote, knows, but they may or may not help you run your business better. You have to, say.
Yeah.
Right? I mean, I'm sure we've all come across people who have a predictive model and it predicts something, but they're not willing to use it.
That's right.
Or that in order to use it, you have to completely change the way you run your business.
Yeah.
Or you have to, have dynamic pricing instead of offering a discount to customers based on size of order, and all these things. And you're like, well, if you won't make that change, then the data's not telling you anything, because it's telling you something you won't use, to your point, that doesn't fit your system.
Yeah.
And that, people have to get over that. I think the good news is, I think the pervasiveness in the media is helping, because now business people assume that any problem can be helped with predictive
That's right,
analytics.
yeah.
And once they get to that point, then they'll just say, here's my problem,
Yeah.
use predictive analytics to help me.
Yeah.
And that's actually a better question
Yeah.
as a data scientist
Yeah.
than the here's my data, tell me something interesting.
That's right.
Hopefully they'll just start assuming
Yeah.
that one of the things they should ask is, can the data help us do
That's
this
right.
better?
Yeah.
And probably it can, and then that starts to generate the right kind of questions, which will help everybody.
Yeah, that's right. And now going around the panels, this is like, so in the next 5 years, right? So again, everybody can pick their top 3, but what are the 3 verticals that you think will most benefit from predictive analytics, based on where we are today and then where we will be in the next 5 years? We can start from that end.
Yeah, I think of course one is medical. Yeah, of course, if you have, actually we need a lot of data. We need to be access of a lot of data. Predictive, I think the difference between predictive analytic to deep learning is in predictive analytic, you need as much as you can to get the data, access to the data.
Yeah.
As long as you have more data, you have more accuracy. It's
Yeah.
different from deep learning that you do neural network and you have to work on the weight.
Yeah.
So for medical, for example, if somebody have some test for his body and he do some similarity testing with, it depends, with tens of people or millions of people, he can get a better diagnostic.
Yeah.
And I think this is a one. I think a second. I think of course autonomous car navigation.
Yeah.
It is very important. The communication between the car and you can expect accident. So. I think the third one, maybe I think in finance aspect. Yeah.
Yeah, I think in terms of impact, I think within finance, I think it's probably insurance, because I think insurance has really struggled with
That's right. Yeah.
analytics.
It's one of the very
Think about a bank.
old school industry. Yeah, that's right.
With a bank, I have all these transactions, so I've been able to do analytics based on
Yeah.
those transactions for a long time. But now
Yeah.
in an insurance company, I have far fewer interactions. It's much
Yeah.
harder to do analytics. But now I've got sensors and I'm starting to get more data.
Yeah.
I think that's going to really change their attitude to analytics. I'm a complete cynic over healthcare analytics because of doctors. And I think it will take a long time to get predictive analytics, because until med school is taught with neural networks and predictive analytics, and where half the instructors at med school are math PhDs, you're not going to change doctors. I think that's a long, slow journey. So I think we'll have an impact in healthcare. I don't think it'll be necessarily as quick as any of us would perhaps prefer. And I agree completely on the transportation, but not just autonomous cars, but transportation more generally. You think about the world's transportation network: ships, containers, ports, vehicles of any kind, and how much of that still relies on people and maps, and that we always do this the same way, the same checklists, all those things, and how much of that could be radically reshaped.
Yeah, that's right. And smart cities,
with
transportation within like
right.
smart traffic lights. Yeah,
All that stuff.
totally. Yeah. Cool.
I'll take a reverse stance than James on the healthcare. I think healthcare will be one of the biggest beneficiaries, and my reasoning
It's
for
a
that.
5-year horizon was my concern. But here we go.
Primarily because a lot of healthcare facilities, major problem for them is actually how can we access our data. We don't know how to. It's there, but we can't access it. So once, and of course it's going to be a slight it's going to be a gradual improvement. But once they get access to that data, there's so much possibilities that they can do with it in different terms. The other support for that, I would say that the very fast developing field in analytics, natural language processing, the biggest application for NLP is in healthcare, specifically reading electronic medical records, et cetera, et cetera. So, and NLP is still developing, and of course that will be, the biggest applicant of it is going to be healthcare. The second field is definitely cybersecurity. It's a recent field, and it's a field that recently discovered application of analytics to its purposes. I think SAS, quoting SAS, 80% of cybercrime can be prevented. I think they said actively, or in other words, you can detect the cyber threat based on the behavior 80 times out of 100. So the opportunities are there, and SAS, I think, released their first cybersecurity product about a year ago or a couple years ago. And And of course, the regular businesses. Marketing analytics is the biggest applicant, and not all businesses are, even in the United States, can appropriately apply it, for their business objectives yet. So this field is also, the more businesses will get on the bandwagon with, with marketing analytics, the bigger and more developed that field is going to become.
Well, actually, I agree with you regarding cybersecurity. Yeah, that's a very important field. But, well, of course, I work in that.
You're completely unbiased.
But as I said, from last year's thing that Naveed will remember, and Naveed should give a talk here next time they have this conference, that if Saul Perlmutter, who's a Nobel laureate in physics, is so interested in data science, what it means is that there are certain applied aspects of physics that really need data science and really need these analytics. They can use this good form of analytics. Gravitational waves threw them off, actually, at first. Yeah, even today, I don't think they have completely understood what gravitational waves are all about. And they can't because there are no proper analytics helping them. I know it's a slightly different type of analytics than used in industries, but this is definitely a field that can use analytics.
So, like, two more.
One more. I can think of one more. Go ahead.
Okay.
So maybe I can sort of flip the perspective around, right? As I was saying earlier, I view data science not as a field in itself, but as a tool. Right? Now, of course, different industries are more or less mature in sort of exploiting the tool or having it in their processes. So I think all industries will benefit, and it's not going to be so much how much data science influences it, but the basic size of the area itself, how we measure the market size. I think what is going to impede things in the short term is the access to data and the regulatory, constraints that you have. So even in the medical instance, for instance, I can't get access to all of the data, right?
That's right.
Clearly, it's used in the marketing and consumer analytics domain. But again, depending on how paranoid you are, or how privacy aware you are, these things are the data you want to get your hands on is not necessarily always legal to access or accessible.
That's right.
So I think at some macro level, those sorts of issues will come into play as well.
Got it. Cool. Now, before we open up the floor, I have one last question. So I think this is gonna. Okay, if we had to pick one thing, that you've seen many analytics projects, right? If you had to pick one thing that goes wrong, like when people try to implement an analytics project or when they try to use predictive analytics for business, like what is that one thing that goes wrong? That's the question. Yeah, if you had to pick one thing. You want to start?
Well, I'll start.
Yeah.
I've always.
I think you want to start.
Yeah. So for me, the key problem is that they don't really understand the decision they're trying to change. They don't really, the business decision, who makes it, how do they make it, how do we tell good ones from bad ones, what are the other factors that can't necessarily be analytical, that might be regulatory or whatever, that have to go into it, and therefore they build an analytic that can't be used, or can't be used effectively, or can't be deployed into the system that has to be present at that time, or can't be delivered to the person in the place they're going to be when they're made it. And so the analytic might be great in terms of mathematically great, but it doesn't solve.
So the implementation part is what you're talking about.
Yeah, that they can't. They build an analytic that won't ever work, or they build it in a way that doesn't quite mesh with the business reality that they're trying to deal with. And that there's too much math and not enough business.
I will answer on the opposite. If it's too good success. So I think there'll be some, in my opinion, some disadvantage to that, because if you looked on maybe on the 18th century and 19th century with the industry revolution that took a job for many workers, I think if we have very, very good success in predictive analytics, it can take a job for higher socioeconomic people, maybe like analysts, people like that. So this is my opinion.
Mr. Bagirov?
If I would have to pick on one, well, I completely agree with James that knowing the objectives that you knowing the questions you want to be answered is the key thing. But the second, I think, biggest thing is data quality. Mm-hmm. You're accruing data over the years, and you think that at one point you're going to hire somebody who's going to come in and wizard out some insight out of it. Yeah. But when they're looking at it, they're saying you have 75% of your values are missing. I really can't do anything. Yeah, but can you maybe do something with it? Just like no, it's really useless. You have to have your strategy. You have to have your understand what questions you want to answer and what kind of data will help you answer that. And then you have to start implementing that changes like a waterfall on every level.
Yeah, that's right. Okay.
I very much liked all the answers that I heard so far, and I would like to say that my answer will probably stun you because I've stuck with physics before. I think interaction with other persons within your team is going to be an important point.
Yeah. Yes.
Because see, you think one thing by analytics, your team members think another thing by analytics, and maybe you don't really understand each other. Yeah. So interaction with human beings is very important.
I'd like to add actually to that. I spoke with a lot of data science team leads, and two soft skills that everybody were looking for, besides obvious one like statistics, coding, it was creativity and being a team player. So those are two biggest soft skills.
That's right. Yeah, sure. And so, what do you think like the one thing that goes wrong with any analytics project? That might go wrong.
So again, it's very context dependent, but I think certain decisions, if they're critical enough, you need to know, why you're arriving at that decision. Yeah. Now, there's two sides to this argument, right? Which is, some people will argue that you must have human intervention and not do everything automated. And on the flip side, there's the argument that things are too fast, and you can't afford to have any human intervention. Right? Of course, that's something that the audience can debate.
So
but I think that's a conundrum, and it has to be done on a case-by-case basis. But there have been disasters that I've been part of that occur on both sides.
Yeah,
right?
that's right.
So get the balance wrong, and
that's right.
You get the balance wrong, and it's
or the problem wrong. I mean, the Facebook fake news example is one of these, right? I mean,
so with that, I would like to open up questions to the audience, because not only are they very knowledgeable and experienced, they're also funny. So you might get a joke out of them too. So please feel free to, so if anybody has a question, feel free to kind of ask. If not, we'll move on to the next topic. Anybody? No questions?
I'm going to say they're still here at getting the end of the day.
That's right.
Having questions as
that's
well.
we can adjourn early.
The bridge too far.
Okay, I'm KRS Murthy. I have some facts. Just in USA, if properly implemented big data, IoT, everything in the full sense, just the data scientists, we need 500,000. These are published numbers. And for us to be able to have 500,000 data scientists, we need to train them in data science, which is different from being a mathematician or a statistician or a programmer or anything. That's a unique field, number one. And we don't produce in USA enough number of mathematics degrees, enough number of any degree related to that, including statistics, is not just mathematics, statistics. Plus, as some of you mentioned, the domain knowledge is equally or more important to have, for which they need to either have training or internship with a senior person in the domain, number two. Number three, when you do the data science analysis, etc., you need to be able to visualize, which is data visualization. I'm putting the dot so the question will automatically pop up. And now when you have the visualization which has to be happening, how do you visualize? Who visualizes it? The decision is made by the C-level suite. at least at the highest level, or the board level. And they don't understand data science. So you need to be able to make it in their image of what they understand, what parameters, how they see, and their metrics in how they see. They need in terms of salespeople, variety of metrics. If it's market research, competitiveness, how to sell, where to sell, customer service. So there are multiple domains it has been translated to, which also requires either collaborative work between multiple fields, or there's one person who has a common understanding as well. You cannot have desperate knowledge people to come and work together. So any comments on how to implement that? There will be a desperate need and big opportunity in the education industry.
So I want to address this one because I'm going to disagree with every single thing you just said.
Okay.
From the very beginning.
Okay.
First of all, we are not 500,000 data scientists short, any more than we were 500,000 Java programmers short 10 years ago, or 500,000 COBOL programmers short, or 500,000 telephone operators short, or 500,000 lift operators short, or 500,000 horseshit shovelers short.
Okay.
If you go back, the reality is we always have these massive increases in demand. And what happens is smart people and technology people and companies figure out how we don't need 500,000 people to do these jobs. So we will never need those 500,000 data scientists. You already see massive amounts of automation being applied to tasks that used to take a data scientist. So I don't believe that number. That's number one. The second thing is I have plenty of companies I've worked with that find that they can teach everything they need with the new modern automated tools to people who don't have math degrees. They just need to have a sense of a willingness to be analytical, small a analytical, think about problems, analyze problems, break them down. Many of those people were driven out of math class in high school and in college because they were told they were not math geeks, right? They wouldn't be a math geek. They didn't think of math the way the math teacher thought of math, so they don't do math, right? So, no, they don't need to have math degrees. I think it's more a question of broadening the pool and getting more people who have different degrees to see this as a potential career, potential way to go. Thirdly, I don't believe that visualization is automatically the key. Most of the analytics that generate the most value are embedded into automated systems to generate scripts or suggestions or prompts or behavior. And there's no visualization involved in that. It's about finding the right algorithm, embedding that into a more robust algorithm and using it to drive the behavior of systems. So I don't necessarily think visualization is a critical thing. And lastly, and perhaps most importantly, the C-suite is not the right target because the decisions they make don't have any history. Each decision is unique. They're one-offs. It's very hard to come up with data. The right decisions are the decisions made at the other end of the organization, the day-to-day decision-making. Peter Drucker once famously said, there's a tendency to believe that only executives make decisions, or that only executive decisions matter. This is a dangerous mistake. So,
okay.
So there we go. It's always good to have a panel disagree, right? So.
Because you've never run a company, right? So you do at a large scale level, you may not understand. So that's the point here, right? As data scientists talking about a corporate executive role, how the decisions are made, right, is very, very important for someone to understand. And machines don't work on their own. Someone has to take the data, curate the data, collect the data, understand the data, and has to feed it. If without the human, everything, the world is not automatic as you may be imagining, right? So there is a lot of data collection, curation. It is not automatically done. And then which data has to be used, which data is not. Machines do not understand. People are coming up with algorithms. Doesn't mean this all happening everywhere in any companies at all. And C-level people are the ones who make decisions, not the data scientists, not the machines which make the decisions to see how much resource allocation has to be done, how decisions have to be made at all. Otherwise, you don't need any of the C-suite people. They may go home, according to you.
I'll take that. So, first of all, about not needing C-suite people, I think last year some Hong Kong-based VC firm actually implemented the first algorithm board member who actually has the voting rights. So it's very possible they will be replaced. But talking about the I think you're referring to the McKinsey study from 2011
Yeah.
about the need in more data scientists and data science and analytically inclined
And
managers.
data has increased multiple times
By
from then because
act-
you need more people.
Right, by the actually next year, 2018. Well, first of all, this is an opportunity for educational sector. In 2015, I think there were about 120 master level programs in data science and analytics in one flavor or the other, and only maybe 10 in bachelor, undergraduate level programs. By the next year, the undergraduate number of programs have either tripled or, I'm not going to quote, but it increased dramatically. So, schools are reacting to that. Also, we have a lot of vocational, the data science boot camps that are actually producing the, to a different extent, they're producing, results in terms of job placements. Again, the shortage of data scientists and analysts that I've seen, been solved as was, for example, data science teams. In McGraw-Hill, for example, there's no one data scientist. There's a data science team with different capabilities, with different competencies. And they all bear a title of a data scientist. So there's a Hadoop guy, there's a machine learning person, there's a instructional design person. They all understand statistics, they all learn from each other, but they contribute their specific focus, their specific expertise to the, to achieving the team effort. So I think while we still have that shortage of, of the talent, analytical talent, data teams probably going to be the most adequate response to.
But not when you look at multiple disciplines, multiple industries, multiple verticals like law. There's a big demand for digesting the data from the text, NLP, etc. to be done. It doesn't happen by itself. In pharmaceutical drug discovery, where you look at protein folding, etc., to be analyzed, to be able to look at the behavior of different small molecules to go into a drug. A lot of these problems are still there, not being attempted because there is no one to look at it and understand except for some retail, except for some sales, that kind of a thing. All domains are now not being covered, so the discipline has been not exploited. That's the point I'm trying to make.
Yeah, so a quick sort of irrelevant comment on the
That's
law,
okay,
on the law business, right?
Yeah.
Because what you say is true, and if you ask a bunch of lawyers, and lawyers have actually approached me on random occasions, and I don't normally interact with lawyers, is they need a lot of things done. The venture or investment or startup perspective on this is that that's not enough of a market, right? Because most of the law firms are boutique guys, and they don't sort of count as enough to have me get a scalable business. So that's sort of, I think, the mismatch.
It's the corpus of document, it's not the number of lawyers. When it's
No, but
litigation,
I mean,
the
somebody
customers,
is-
right? So the number of documents is enormous, but the people who are willing to pay you, that's what he's, I think
Right.
that's what he's
I
referring to.
I understand, that's at the venture level.
Yeah,
today,
that's exactly, yeah.
Not that they understand
Right.
law.
So-
like-
Oh, no,
So
it's
the-
only purely, is it a venture fundable business or
So
not?
the problem is there, but I guess it's not enough of paying customers.
And similarly EMR, PHR, EHR, I'm just giving supply chain. And all the infrastructure in the oil industry and many other energy industry and transportation industry, if IoT at all is deployed, then a lot more data will be generated. And already data has been, CAGR has been about 70%. In the last few years, that has not stopped, does not reduce.
Yeah,
It's only will multiply or accelerate the way it will have.
yeah.
So that's how I'm trying to make it look like with this not industries being looked at. Maybe there's not a capital intensity. So
Yeah.
that's what you're talking about.
No, the thing is,
Venture capital intensity.
it's more about like it's a delicate trade-off between, hey, okay, if I'm a data scientist and I want to focus on this particular, let's say I want to specialize in
Yeah.
law, for example, right? The thing is, the demand also matters, right? Is it like, will I only specialize in this very narrow thing, or will I be able to address a huge problem? I think that's one of the reasons that not every single vertical is being attacked by data science, because it's a combination of people's interest, and also is it venture fundable, because somebody has to put money into it.
It's called venture capital intensive.
Exactly, yeah.
That's the technical word for that, right?
So, and that's why I think to address the question is that trade-off. If to make the playing field level, then people will equally enter all the fields. But right now, autonomous vehicles, for example, a lot of very huge demand. So people want to become a data scientist in that domain. So yeah,
I think I'd back Feyzi's comment too. I think the biggest mistake people make is that they want to hire data science unicorns. They want to hire the one data scientist who will be able to do everything. Yeah. And every single company I've met with that is successful, that is not a LinkedIn or a Facebook or a Google, right? So an actual sort of traditional company, so not a modern data-only company. Yeah. Their teams are a mix. And they might call them all data scientists, or they might call them different roles in a data science team, or they call them something else. But they have a broad base of skills across a broad group of people. And they focus on how do we get these people to collaborate, how do we get non-technical people in. Yeah. And then they don't have the same recruitment problem, because they can recruit from their own organization and train them in skills, and they have a lot more options. And I think the ones who struggle is the ones who look at a company like Facebook, LinkedIn, who have a certain style of problem and say, oh, I've got to solve my problems the way they solve their problems. And you're like, if they're in a completely online, data-driven company, and you're a paper goods company that turns trees into toilet paper, then you don't have the same problems they have. Because they don't have any trees or toilet paper or trucks or factories or anything, right? Yeah. So, I think people have to sort of stop trying to say, I'm going to just copy what the people in Silicon Valley are doing.
The companies of one kind have more difficulty attracting talent than, say, a Google or Facebook. That's also another problem. And if you go into Google, then they'll make you work on certain aspects, right? As opposed to if you go into, I don't know, say, pick a company, Walmart or some other paper company, for example, right? It's a very different.
But the head of analytics for Ford had an interesting comment. He said, yes, we do all these interesting things about autonomous vehicles and this and that. He said, but we also spend a huge chunk of our time on the basic blocking and tackling of how we run the factories and how we make the cars and how we deliver the steel. Because if we don't do that, there's no money.
That's right.
The whole thing. I can't just do the fun things. I have to use analytics to improve the day-to-day operation of the business.
That's right.
To generate the money that will let me do this more.
That's fine.
Well, that was
And Professor, you mentioned 120,000 people have been trained for data scientists. I don't think it's within USA. People are coming in from other countries doing it. Well, so look at it. There's not enough universities which are producing degrees.
I mean, I can only speak for what I teach. I don't know, you can speak for what you If I look at the students I have in the extension class that I'm part of at University of California, Irvine, I would say 95% of the students are US based.
Okay.
What about you?
I think a couple of years ago, I was approached by a university in India, online university in India, that was asking me to teach on the online basis, the data science on online basis, and the courses were supposed to be synchronous. So I would have a session, which didn't quite work out for me because of the time difference. But in our conversation, I actually asked, what is the demand for that in India? Like, how much of a demand on the data scientists is there? Because actually, a year before, I was trying to implement another project, analytical project overseas, and I found out that the levels are just not there as they are in the US. And they said, well, there's a huge, from companies, it's not much of a demand, but from the students, there's a huge demand.
Maybe they're aspiring data scientists.
Right, the students wanted, the degree wasn't, my understanding, the degree was in demand because students were aspiring to get a job in the places like US or, Europe, where that kind of knowledge isn't actually.
So I guess I have a question for you, and this goes back to the
sure,
conversation the two of you were having, right? So do you think it's real that there are these 500,000 jobs, or is it false that there are none? I mean,
is it fake news?
I do not believe we are 500,000 data scientists short. No. think there are lots of companies that, in theory, would like to do more data science, and they say they can't hire data scientists, but most of them do not have hundreds of job postings out there for data scientists, for which they're not getting applications. It's a theoretical calculation. Yes, if every company was to take all the data they had and use it effectively, they would need many more people to do it. Right? But most of them, the reason they're not doing it is not because they can't hire data scientists, it's because they don't want to do it.
Exactly. So
that's the point.
My question for him was, given that reality, are we sort of just fooling ourselves or fooling the to-be data scientists by sort of, hyping up this the potential for it, or are we missing something here? I mean, I'm missing something here. I'm trying to figure out what it is.
I want to go back to a point that you made a little while ago about visualization.
Yeah.
Do you know that data visualization is a very serious problem, and that I personally know a government agency that I will not mention by name, where the management do not understand anything unless you give them flow charts. The trouble is that, so if you're a contractor for that government agency, you have to give them flow charts, otherwise they won't understand anything. Now, that does not work for the contractors all the time. Their researchers there, they like to do graphs and other types of visualization techniques. But the problem is that when they work with this government agency, they get into the trouble. So within the same organization, or when an organization interacting with another organization, the whole question of data visualization is actually a very serious problem. And the data scientists should address that.
And also, decision making has not been holistic in nature.
Mm-hmm. Yeah.
Look, again, one of you mentioned holistic in nature in terms of how the different functions of the departments are connected. How the different, not only in the organizational one, but in the infrastructure are connected. How the supply chain is connected. Supply chain analysis. If it is done well, assuming that there's capital intensity to put in, there's a lot more can be done for all the machines learning that is being done to be utilized. If it's not properly utilized, we'll have developed a lot of machine learning algorithms that's never going to be utilized. It's like a vicious circle I'm trying to think through. Where is the mismatch?
Perhaps we should poll the audience.
I think that was the reason we opened it up to the floor.
I would say something.
Go ahead.
Actually, I just attend Google Cloud, Next, right? Conference in San Francisco, right? The Google Brain, head of Google Brain, Jeff Dean, right? Very famous, yeah. Google's already internally, they have over 1,000 projects using machine learning, deep learning, and Google is developing a lot of things push over. They just hire, very famous professor from Stanford, right, to lead their Google Cloud for machine learning. Yeah.
Okay.
So they develop a lot of automate kind of a cloud-based tool, and we can use, right? And same thing is happening in Amazon Cloud and Azure, Microsoft, right? They all developing this kind of machine learning, deep learning, algorithm, automation, and visualization, sell to all kind of us to use that, right? So don't worry about any shortage of data scientists, because just like a lot of companies, data science is very expensive, right? Not many companies are willing to pay this kind of salary. Just hire a guy can do everything, right? They can hire different component, can do in data engineer, they can do architect, right? So what will happen in the last 2 or 3 years? So actually, from data science, actually when teaching at the university, actually we need the basic mathematics, the basic function. We need it. This is the building blocks.
Yeah.
So what happened in the last few years is that the computing capability jumped very, very high. So
Yeah,
they become different type of algorithms. So look what happened is in computer vision. So 40 years people teach, edge detection, computer vision, things like that. Actually, Hinton and his friends came in, finds a convolutional neural networks. Everything will change. So all what we teach in university, thousands, tens of thousands of students, everything will change. So what is Google is doing now? It's a new type of education. Their education is based on the rapidly advance of the computing. So it's different type of algorithm, different way different mathematics. So I think maybe we have to think about in the university, maybe we have to because the computer didn't change until last few years. It was, the volume. Now there's so many types of computing that it's not only computing, it's not only speed, it's different type of algorithm. Now they can do neural network to a lot of data that 50 years people couldn't do that.
And
So
that's
it's
a very good point,
aspect.
because the kind of data science that you do is very dependent on the underlying the infrastructure, right? Like for example, 25 years ago, you can't just come in and say, I'm going to use a deep neural net because it's going to take like 10 years, 10 weeks to kind of build anything meaningful, right? Now we have GPUs, NVIDIA is coming up with like new GPUs every week, and that is kind of fundamentally changing the way we
They
think
even have a
about
board they showed in the, he was there. There was a big machine learning conference on Saturday in Stanford. He was there.
So the underlying
Well, I think it's
hardware
splitting,
makes
right?
a lot of difference.
It's splitting. It used to be that if you were a software company or a university or a big enterprise and you wanted to do analytics, so I used to work at Fair Isaac. So if you were like the kind of people that they would hire to build risk models, but the same kind of people that a bank would hire to build risk models, which were the same kind of people that SaaS would hire to learn how to build the software to build risk models, which were the same people that universities would hire to teach. It was very seamless. We were all math PhDs with the same set of skills. But now more and more of that stuff is embodied in software, embodied in machine learning, embedded in these cloud-based learning systems. And suddenly what universities need and what software companies need is not what enterprises need.
That's right.
Enterprises no longer need PhD mathematicians to build analytical models. They need people who can use the wonderful software tools that have been built by other people's PhDs to solve business problems.
Right.
And so the skill set has to shift, and that's why I like the Feyzi about these teams, because it lets you be a bit fungible as to exactly.
You don't morph into anything kind of.
Because you don't necessarily, this sense that everyone's got to hire the same kind of person, and it's like no, the kind of people Google needs to hire to build these things are not the kind of people that the paper goods company needs to hire to figure out how to route its trucks more effectively. That's
Who will
a
make
different
cool?
problem.
Who will make cloud cool? We
And
use
I
that.
think we have to start to split these threads, tease these threads apart from each other. So you need hardcore math skills to do some of these things, but enterprises don't need hardcore math skills.
And I would like to actually add to that. So there's that whole dispute, sort of wars going on. How's data analysts different from data scientists? And we all know that there's really not much difference. But and DJ Patel was the one who coined data scientists first at LinkedIn, and that's because a lot of jobs, the internal job description, were coined data scientists, and then it was popular. However, I see in different talks from different people, I see some some people prefer to call data analysts people who know how to use analytic tools and who are using it, and data scientists are more people who are building those tools. So we would probably think about data scientists working at Google, automating a lot of stuff that then data analysts can use and produce an insight for the company.
And then there's data engineering too, because
Of course.
it's really more fun because
Yes.
for example, in people using Hadoop and Spark, it's kind of that's when data engineering becomes really important because of the data that's flowing through. So
Absolutely, and speaking about the automation, I think it's in the process. I was talking to I was at some meetup startup meetup in San Francisco. And there was an idea floating around of building a tool that will actually make marketers' job easier. And I was thinking, well, that's what the mission statement for RapidMiner is actually. The company that's has from 2 years ago from Germany. So there's a lot of ideas floating about automating it. a lot of, I mean, less people are afraid of the word coding.
Yeah.
So, and they're
Yeah,
coming
yeah,
somewhere,
yeah.
and they're coming somewhere in the middle,
Yeah.
where, for example, with the R, you know how to code, but then you're using R Studio, which makes your job a little
Yeah.
easier. So, I think this tendency will actually grow, and a lot of stuff is going to be automated.
I think with
Yeah.
that, I think we were running out of time, so I think with that we need to wrap up. But please feel free to kind of interact. But yeah, it was a really great
Yeah.
session.
Yeah.
I'm
Yeah.
sure.
Yeah.
Hope you enjoyed it. But
Good, very good.